Okay, this is lesson 2.8, absolute value functions. Learning goal is to represent absolute value functions, and we'll start out with the general form of an absolute value function. Okay, the general form is y equals ax, absolute value of x minus h, close absolute value, plus k. Now, absolute values are the graph of them are v's, and the v's, the point of the v, we call that the vertex. Okay, so this general one has a vertex at hk. And these are the coordinates of the points. The x coordinate is h and the y coordinate is k. I want to point out something about the h. If you look in the absolute value problem, there's a negative in front of the h. In the vertex, it's no sign, which means it's positive. So there's something that we need to know about the h. The h in the problem and the h in the vertex, are there always opposites? Let's take a look at k. It's plus k here, and we have k without a sign, which means it's positive. So what this tells us is that whatever sign k is, the k in the problem and the k in the vertex, they're the same sign. It doesn't mean they're always positive. The fact that this is plus and there's no sign here, we can take that it means they always have the same sign. So hk, h is the opposite, k is the same. I've heard it said before that h lies and k tells the truth. That might be another way of remembering this. Okay, talk about the effects of a, and that's the number in front of the absolute value symbol. Okay, these are kind of short absolute value symbols. I couldn't find one in this software that was any longer, but that's the absolute value symbols right there. Okay, so here's what we know about a. That number in front, and sometimes there's not a number, but when there's not a number, there really is a number. It'd be positive 1. Okay, if a is greater than 0, which is another way of saying positive, then the v opens up. And here's an example of one. If a is less than 0, and that's another way of saying that a is negative, if a is negative, then the v opens down, like this one. Okay? Other things about a, the absolute value of it. If the absolute value of a is equal to 1, now let's think a second. What numbers could we put inside here where the absolute value of this would be equal to 1? That would be a 1 or a negative 1. So there's really only two values. So if the absolute value of a is equal to 1, and again, that could be no number in front, and that would mean it is positive. Okay, so if the absolute value of a is equal to 1, then the v is what we call normal, or a 90-degree v, like this. Sometimes I say it sort of resembles the corner of a piece of notebook paper. All right, and that could be negative 1 or positive 1. If the absolute value of a is greater than 0, which would include 1.1, 5, 10, negative 5, the absolute value of negative 5 is greater than 0, and the absolute value of negative 3/2 is greater than 0. Any one of those numbers, if the absolute value is greater than 0, then the v is a more narrow than normal. And an example of that might look like this. And if a, the absolute value of a rather, is tucked between 0 and 1, so we'll say it's going to be greater than 0 and less than 1, and that would include proper fractions and decimals like 0.1 or 0.7 or negative 0.6, because when you take the absolute value of that, it's still between 0 and 1. Then we say that the v is wider than normal, and here's an example. Okay? All right, moving on. One of the things that we're going to do is we're going to graph absolute value functions. To graph, you must pick the right 5 x values for with the vertex in the middle. Okay, so let's take a look at this first example 1. Y equals negative, but now remember there is a 1 in front of that, right? Negative 1, x, absolute value of x plus 2 plus 3. So our first thing we would do would be to write down what the vertex is, and I like to write it right underneath the problem so I can work on my signs. I see positive 2 here. I know h always lies, so it's going to be negative 2 down here, and this is positive 3, so k always tells the truth. It's the same sign, and that's our vertex. Okay, so if we're going to graph this thing, we want the vertex to be in the middle. So I'm going to put the coordinates of the vertex in my 5-point chart over here, -2, +3. And then I'm going to pick the x values that are the 5 correct x values. Okay, so what I want to do is I want to count up by ones from -2. What's 1 bigger than -2? -1. That's my next value. What's 1 bigger than -1? 0. Okay, counting down, 1 less than -1, -2. 1 less than -2 is -3. 1 less than -3 is -4. So these 5 points are the ones that we're going to use. Okay, now the next thing to do would be to plug these x values into our problem and find out what the y value is going to be. Okay, so let's put in 0. I think we can do this in our head. 0 plus 2, well, that's 2. Then I take the absolute value. You do absolute value like you do parentheses, work inside and then go out. So the absolute value of 2 is 2, and then this negative is applied. We have -2 now and 3. So I'll go over that again. We put a 0 in here and we add 0 to 2 and we get 2. We take the absolute value, that gives us +2. Then we apply the negative that's on the outside. It's got nothing to do with this absolute value. Then we apply that negative that's on the outside. Now we have -2, and we add 3 to that, and we get +1. So that value is +1. So the point 0, 1 is on our V. All right, let's plug in negative. Let's plug in -1. Okay? All right. So we put -1 in here. -1 plus 2 is 1. The absolute value of 1 is 1. Apply the negative and we get -1. And -1 plus 3 is 2. That value is 2. Now we're going to learn something on this first problem. And after we learn it, we're going to be able to take this. It's going to be a shortcut. And we're going to be able to take it from now on. All right, let's plug in -3. If we put in -3 here, we get -3 plus 2, which is -1. We take the absolute value of -1, that gives us 1. We apply the negative on the outside, so we have -1 plus 3, which is 2. So this is 2. All right, and now let's do -4. All right, plug in -4. So we have -4 plus 2. The absolute value of that, which is the absolute value of -2, which is 2. Apply the negative that's on the outside, plus 3 equals 1. Okay? Now, because we picked our vertex to be in the middle of 5 consecutive integers, then there's something special about this, and I want you to see this. Look at this value of y, and look at this value of y, and compare this one to this one. Okay? They're always going to be the same if you pick your x's like I told you. Start with the vertex, go up by ones and down by ones. So from now on, when we're filling in this 5-point chart, once we do one of these, we'll just come down here and write the answer in. Once we figure the second one, and you could start from the bottom and go up, that would be fine as well. All right, now we're going to graph our points. So let's find 0, 1. That's a point on my V. -1, 2, another point on my V. -2, 3. -3, 2. -4, 1. And now we'll draw a line. And here is what this looks like. All right. So there's our V. Now let's take a look at it. Does that look like it's a 90-degree V? I think so. And what's the number and what's the absolute value of -1? It's equal to 1. The number is also less than 0, so it's negative, and it did open down. Okay, so we see the effects of A there. All right, here's a problem for you to work. Go ahead and take a minute. I'll stop the video, come back and show you the answer. Okay, that should have been time enough for you to do it. Again, we'll put the vertex under here. The opposite of -1 is 1. Whatever this is the y. the vertex is 1, 1. Counting up, I go to 2, and then 3. Counting down, 0, negative 1. Let's see. I think let's plug in 3. So if we put 3 in here, we get 3 minus the absolute value of 3 minus 1, which is 2. Absolute value of 2 is 2. Apply the negative. Put plus 1. They don't always have a negative out here, but the first two have. And so we get negative 1. So when we plug in 3, we get negative 1. But that's negative 1, but so is that. We don't have to plug them both in. All right, let's plug in 2. Okay, so we have negative absolute value of 2 minus 1 plus 1. Negative absolute value of 1 plus 1. Negative 1 plus 1, 0. And there's a 0. That's a 0, but so is this. Okay, we graph this thing. At 3, negative 1, that's a point on our V. 2, 0, that's a point on our V. 1, 1, 0, 0, negative 1, negative 1. Draw the V. So we have a V that opens down. And it is what we would call normal because the absolute value of A, the number in front is a negative, but it's negative 1, and its absolute value is equal to 1. All right, let's try this one. Give you a few minutes to try this one. We'll come back and work it. Okay, before I actually graph this, I want you to take a look at this and tell me, let's see if we can understand the effects of this A, okay? All right, so this is 0.5. It's positive, so I know this V is going to open up, and the absolute value of 0.5, is between 0 and 1, isn't it? Which means this should be a wider than normal, and the normal one we call is the 90-degree one. So that's what we're going to expect to find, a V that opens up that it's wider than normal. Let's see if that's what we get. All right. So first thing would be to write down what the vertex is. The vertex is the opposite of this, and whatever this is, we put that in the middle, 2, 2. Go up by 1, 3, 4, down by 1, 0. And let's see, let's plug 4 in. So we have 0.5 times the absolute value of 4 minus 2 plus 2. 0.5 times the absolute value of 2 plus 2. 0.5 times 2 plus 2. 0.5 times 2 is going to be 1, and 1 plus 2 is 3. So when we plug in 4, we get 3, but that's 3, but so is this. We don't have to plug them both in. All right, let's plug in 3. 0.5, 3 minus 2 plus 2. Working inside the absolute value, 3 minus 2 is 1. Evaluate the absolute value 1, and we get 1. 0.5 times 1, 1 times anything is itself. Add 2 to 0.5 and get 2.5. 2.5 here, but also here. Why is that true? The way we pick our x's makes this happen. It saves us a lot of work. All right, let's graph this. At 4, 3, we have a point on our V. At 3, 2.5, that would be right about in here. At 2, 2. At 1, 2.5, and 0, 3. Putting in our line or graphing it. And what we have is a V that opens up that's wider than 90. That does not look like a corner of a sheet of paper. Okay? Let's give you another one to try. But before we do it, let's think about what we're going to get. Look at the A. It's positive, so it tells me that the V opens up. And the absolute value of 3 is greater than 0, which should translate into a more narrow V. Let's see if that's what we get. You go ahead and work it. All right. First thing, right? figure out what the vertex is. H is always the opposite of this. Opposite of positive 3 is negative 3. K is always whatever this is. I see minus 2, I write negative 2. Put my vertex in the middle, negative 3, negative 2. Counting up by 1s, negative 3, go up 1, negative 2, go up 1 from that, negative 1. Go down 1 or smaller, negative 4, negative 5. Okay? Plugging in negative 1, 3. Absolute value negative 1 plus 3 minus 2. Working inside the absolute value. Negative 1 and 3 is 2. Evaluate the absolute value of 2 and we get 2. Multiply 2 times 3, we get 6. And 6 minus 2 is 4. That's 4. And so is that. Let's put in negative 2. 3 times negative 2 plus 3 minus 2. Working inside the absolute value. Negative 2 and 3 is 1. Absolute value of 1 is 1. 3 times 1 is 3. 3 minus 2 is 1. That's 1. And so is that. Okay, we graph it. Negative 1, 4. Negative 2, 1. Negative 3, negative 2. Negative 4, 1. Negative 5, 4. And connect the dots. And that's what our V looks like. Okay? All right, let's see. Okay, now this is a little more complicated problem. It's sort of like it's working backwards, and sometimes walking backwards is even difficult. Working the problem backwards could be difficult as well. But let's take a look at it. Example 2 is to write the equation of an absolute value function given the graph. So here we have the graph, and I've got 2 points that are sort of highlighted. Now what this means in the text is it means that you can figure the coordinates of these points out with certainty, which means they should be integer coordinates. So for starters, we'll just go ahead and write the coordinates down of these points that they've sort of highlighted. Here it's 2, 1, and here, this is obviously the vertex, is 0, negative 3. Okay? Now, let's go through this. I'll try to color coordinate it too. Okay, so number 1 is to write the general equation of an absolute value. Now that was on the first screen that we had, and that's y equals a x minus h, absolute value, plus k. All right, write the general equation, and we did. Okay, step number 2. Plug in h and k from the vertex. That's my dog in the background. She wants to go out. I'm not going to be able to help her. We may hear another bark or two. Okay, well remember, the coordinates of the vertex are hk. So this is 0, so we're going to plug this in. Y equals a x minus 0, and then whatever this is, negative 3 is what comes behind it, so I'll put minus 3. All right, simplifying that inside here, we get a absolute value x minus 0 is just 0 minus 3. Well, that completes step 2. Step 3, plug in x and y from the other point. So this is the x and the y that we're referring to, this other point that's been highlighted, and they're always going to give us 2 points. Okay, so here's the x and here's the here's the x and here's the y. So the y value we put in is 1. The x value is 2. And step 4 is now solve for a. So really, there's only one variable in this thing we can do this. Okay, so 1 is equal to a, evaluate the absolute value of 2. What is it? 2. And then what's 2 times a but 2a minus 3? We're solving for a. We want to get a by itself. We get rid of the negative 3 by adding 3 to both sides. 4 is equal to 2a. And then we divide both sides by 2 to get a by itself, and now we've solved for a. A is equal to 2. Solve for a, and I have a feeling you cannot read this, and plug A into the answer of step 2. So here was the answer to step 2. So we're going to take this answer here, what A is equal to, up to this line right here, and that will give us our answer. If I put in 2 here, I get y equals 2 absolute value of x minus 3. That's the equation of this absolute value. All right? All right, let me give you one to do. Okay, go ahead and write the equation of this absolute value. And you should recognize it as absolute value because it's a v. Okay, first step is going to be, let's get this in a different color. First step is going to be to write the coordinates of the vertex. Well, this is at 0, 2. And what's the coordinates of the other point? 2, 3. Step 1 is to write the general equation of absolute value. Now, this is not going to be given to you on a test. You're going to have to memorize what the general formula is. So this comes out of your head. Step 2 was to plug in h and k. Well, this is h and this is k. So we plug that into our equation. It's x minus 0, and it's a positive 2, so it's plus 2. Simplifying inside the absolute value, x minus 0 is just x. So when there's no number after x inside, then the number is really 0. Okay, plug in x and y from the other point that we're given. So the y value is 3 from that ordered pair. The x value is 2. Solve for a. 3 equals a times 2. Evaluate the absolute value of 2. Multiply 2 times a and get 2a. Solve for a. Subtract 2 from both sides. 1 is equal to 2a. Divide both sides by 2. Use the symmetric property. A is equal to 1/2. Take that up to this line here. No room up there, so I'll drop the answer down here. And the answer is going to be y equals, instead of a, I write 1/2, absolute value of x plus 2. Okay? Give you one more to try. Go ahead and do this one. Tell me what you think a is going to be, positive or negative. That's right. It's opening down, so it's negative. All right. Should have had time enough to do that. The coordinates of the vertex are 1, 1. The coordinates of the other point that's highlighted is -2, -1. The general equation of an absolute value is absolute value of a. You're going to have to memorize this. I'm going to say that again. Plus k. Plug in h and k. Remember, h is always the opposite of what it's in the vertex is what it is over here. So I see positive 1 over here. So if that's -1, they're opposites. I see positive 1 in here. These have to be the same, so it's +1. So I've put in h and k. Now I put in x and y from the other point. So it's -1 equals a absolute value of -2 minus 1 plus 1. Okay, solve for a. Simplify inside the absolute value. -2 minus 1 is -3. Evaluate the absolute value. The absolute value of -3 is 3. Multiply 3 times a and get 3a plus 1. Solve for a. Subtract 1. -2 is equal to 3a. Divide by 3. Use the symmetric property and turn it around. A is equal to -2/3. Well, negative's down, and 2/3 is between 0 and 1, so it should be a wider than normal, and that's what I see up there. Take this up to here, plug it in. Y equals -2/3 absolute value of x minus 1 plus 1. And that concludes the video.